In this question, it is given that let S1, S2 and S3 be three sets defined as below. Then the set S1 intersection S2 intersection S3, you have to find the correct choice. First of all, let us check the set of all the complex numbers belonging to the set S1, S2 and S3. Keeping this result in mind that mod of Z minus Z0 less than equal to R represent the set of all the complex numbers lying inside a circle with center Z0 and radius R, including the points on the boundary because equality is present. That is, mathematically I can say this equation represents a disk with complex number of center as Z0 and radius R. Had it be equal to R, then I would have told that this equation represents a ring. Hence I can say this equation represents a disk with complex number of center as 1 plus 0 iota and radius root 2 and all the points inside this circle also. That is, and now see what this equation represent. To understand the set of all complex numbers belonging to the set S2, let Z is equal to x plus iy. Then 1 minus I into x plus iy has real part as x plus y, and because it is given that real part of this is greater than equal to 1, hence we conclude that x plus y should be greater than equal to 1. Clearly, to draw the graph of this, first of all I draw the graph of x plus y equal to 1, and this is the graph of x plus y equal to 1. And because actually I have to draw the graph of this, hence shading will also be there, and to check on which side shading will be there, on this side or on this side, the most convenient point is origin. Origin doesn't satisfy this. It means shading will be on this side. Hence I can say real part of this greater than equal to 1 set of all the complex numbers lying on this side. And lastly, imaginary part of Z is less than or equal to 1. Note that this point was also 1, this point was also having y coordinate 1. Imaginary part of Z is less than or equal to 1 means to satisfy this condition, Z should lie below this line passing to 0, 1. This is x-axis, y-axis. All the complex numbers lying here will satisfy the condition of the set S3. Hence, to check all the complex numbers belonging to S1 intersection and S2 intersection S3, I draw all the three graphs, this, and this in the same complex plane. That is, this is 1, 0 as center and radius as root 2. Because this length is 1, this length is root 2, obviously this point will also be 0, 1. And therefore drawing this graph in this plane, I get this line and shading on this side. And third condition means the complex number should lie below this line passing through 0, 1. This is the line passing through 0, 1, and to satisfy the condition of S3, the complex number should lie below this line, that is hence to satisfy all the conditions of S1, S2 and S3, we have to find the common shaded portion. Common shaded portion is given by that is, I can say the complex numbers lying in this common shaded region will belong to the set S1 intersection S2 intersection S3. Hence we conclude that A is the correct choice.